All right, we're going to be talking about section 5.2 today, which is on verifying trig identities. And you might be thinking to yourself, wait, haven't we done that? And the answer would be, yes, we have. And so, honestly, I'm not sure exactly why they split these into two different sections. But we're just going to do a little more practice on what we've done. So, all I really have is two examples for you today. Just more of a let's get our brain in the right spot, and then let's revisit this idea about what's going on with this negative angle stuff on that you can see on part B. All right, so to get started, again, we're just going to verify this trig identity. Hopefully, by the time you do this lesson, you're pretty well versed at this, so this should not be a big deal. And I think the method I would take on this one is turn everything into sine and cosine, because without that, I don't really know what else to try. And so let's see where that takes us. So I've got cosine of x plus sine of x times tangent is, so times sine of x over cosine of x. Now I've written it just like this, of course, but it's multiplication. So that means really we're just going to have, that's all just one big fraction at that point. All right, and so I think a common denominator is going to be necessary. So I'll multiply both sides by cosine of, or not both sides, how dare you, top and bottom by cosine of x. So that's going to give me cosine squared x over cosine of x plus, and then that turns into sine squared of x over cosine of x. And I think we can all see where this is going. I put them together now in one fraction because I'm not skipping any steps, showing the logical progression. And of course, that is just 1 over cosine of x. I don't really think any notes have been necessary. The steps that we're taking are all pretty obvious. And then, of course, 1 over cosine is secant of x. And that's what we were going for. Therefore, we are done. All right. Pretty straightforward. I would consider this definitely one of the easier ones that we would face. But also, in reality, probably we're not going to do ones dramatically harder either, right? So we just have to have this skill in our back pocket. Okay, and then let's take a look at this guy right here. Now, for a few reasons, this negative angle, this negative theta is troubling for me. The main reason it's troubling is because when I look over on the right side, the goal of this is not to be talking about negative angles. It's to turn this into things of secant of a positive angle. So somehow I have to turn this from a negative angle discussion into a positive angle discussion. And this is really not hard, and I don't know if I've really done a good enough job discussing this. So let's try this again. All we really need to do is think about that you don't want to talk about cosine of negative theta. They're telling you cosine of negative theta. They're talking about it. You want to change the conversation. And so if we just think about, in the most general sense, what it means to have an angle theta, which we'll just assume is like right here, and then its opposite of negative theta would be right here. I don't really like how that turned out. I'm going to erase it and try again. Okay. Well, we know that the cosine of an angle, so if we look at the cosine of theta, it's going to be using, we'll just label this like A and B. A is positive, B is positive, C is positive. If I look at negative theta, then A is still the same number. B is actually just the opposite, negative B, and C is still C. So if I find the cosine of theta and comparing it to the cosine of negative theta, that's just using A over C both times. It's getting the exact same value because it's using the exact same numbers. So we know that cosine of negative theta is exactly the same thing as if I wanted to talk about cosine of theta. So why don't we just talk about cosine of theta? This shows up graphically. When we graph cosine, we know we start at the high point and then we go down and then we come back up and then we go all the way up. Well, that is mirrored on the other side. So whatever I do this direction, positive theta, and whatever I do this direction, negative theta, wherever we go, however far out we go, it's going to give the same values on either side. So cosine of an angle is equal to the cosine of the opposite angle. So however you want to look at this, just understand kind of how to figure it out if you don't remember. But really, this is a pretty straightforward concept. All right. And then what about sine of negative theta compared to sine of theta? So same argument. Let's come back up to our picture. Clicker's not working. This time, when I look at sine of theta, I have b over c. And when I look at cosine of negative theta, I get negative b over c. So one of them gives me b over c. One of them gives me negative b over c. I want them to be the same, right? They're opposite. So how do I write an equation? Because equations are all about equal. And if I put an equal here, clearly that's not true. So what would make it the same? I would have to take this answer and make it the opposite, right? The opposite of the left side now equals the right side. So let's think about this and what we're talking about with sine and cosine, or with sine. So sine of theta compared to sine of negative theta. Now I just put an equal sign there, and we just decided they are not equal. Sine of theta is not equal to sine of negative theta. So what do I have to do to make this a true statement? I would have to turn sine of theta into its opposite. So now I find the sine of theta, and I take the opposite by having a negative out front, and that'll make it the same answer as the sine of the negative angle. They're opposites. Okay, so what does that do for me? That's going to simply allow me to, let's start from scratch. I would probably definitely put a note on this one, and I would say, note, hey, don't forget that we know that cosine of negative theta is actually exactly the same thing as cosine of theta. Also, the sine of negative theta is in fact just the opposite of sine of positive theta. And in that way, we can stop talking about negative theta altogether, and we can talk about positive theta. So this is just going to turn to cosine of theta over 1 plus a negative, so minus sine of theta. To the casual observer, it would look like for sine, we pull the negative out of the angle and put it in front. That is not what we're doing. Is that sort of the direct, like it looks like we're doing that? Yes, but that's not what we're doing. And to prove that point, we're definitely not doing that on cosine, because that negative just goes away. But again, it doesn't disappear. This is based on logic and math. All right. So now we are where we are, and there's really nothing obvious to do. There's no math to be done. The best I could do is maybe turn sine and cosine into versions of cosecant and secant, but that doesn't seem terribly beneficial or fun. And so then that brings us to the idea of multiplying by the conjugate. So again, personally, I could kind of argue that we won't need to show the step, especially because I didn't give myself a lot of room. So actually, let me, if I was going to show the step, what I really had to do is do it on the next line. So cosine of theta over 1 minus sine of theta times 1 plus sine of theta over 1 plus sine of theta. Because if I showed it on the line above, then it looks like I'm jumping straight from the original question all the way to like 2 or 3 things going on. So we usually only want to do one thing at a time. So either show the math on the next line, or if it's not too extreme of a move, to show the result. And the result of this would, of course, be cosine of theta on top times 1 plus sine of theta. On the bottom, we have multiplying conjugates, so the middle term is going to cancel out. I'm really scared that some of you are going to forget about FOIL altogether and always just think there's 2 terms here, but I'll let that go. All right, so here we are. And then 1 minus sine squared of theta. Really, at this point, probably not worthy of a note, but just in case someone needs to see it, we're going to go back to our good old friend, the Pythagorean theorem for trig functions. And I can see that if I subtract sine squared, that gives me cosine squared theta equals 1 minus sine squared theta. Or x in this case, excuse me. Oh, or theta, whatever. Pick the unit of measure. And so 1 minus sine squared theta, I can turn all of that into just cosine squared. All right, continuing my little messy streak here. Now, I can cancel out one of the cosines or the cosine on top with one on the bottom. Now, if you compare this line where we're at to this line, they seem very similar, except now I just have a binomial on the numerator instead of the denominator. But that is actually a pretty important development, because we know that we have simply here the distributive property of division, right? We've got two terms on top divided by cosine of theta. And so that just means we could break this into 1 over cosine of theta plus sine theta over cosine of theta. And 1 over cosine of theta is secant theta, and that would be tangent of theta. And if I'm not mistaken, that is what we were trying to show. All right, so other than the kind of discussion again about the negative angles, most of that should have been pretty straightforward for you at this point. All right, so let's just sort of summarize what we've talked about so far over the last two sections in terms of how to verify trig functions. By all means, this is not a work down the list, do number one, then do number two, but these are just things to consider. So rule number one, it says work with one side of the equation at a time. It's often better to work with the more complicated side first. In general, that's a good statement. For us, we are always going to do the left side, but everything else in that statement is good. Number two, look for opportunities to factor an expression, add fractions, square a binomial, or create a monomial denominator, i.e., that means multiply by the conjugate. So if you summarize that statement, it's basically saying, do math. If there's math to be done, adding things, factoring things, simplifying things, then go ahead and do that. Other things, look for opportunities to use fundamental identities. Note which functions are in the final expression you want. Sines and cosines pair up well, as do secants and tangents, and cosecants and cotangents. Okay, and why are they talking about that? Because if you think about those three Pythagorean identities, those are the pairings that they have. Sine and cosine are in the equation. Secant goes with tangent, and cosecant goes with cotangent. If all the guidelines do not help, try converting everything to sine and cosine. And then part 5 is my favorite piece of advice. Always just try something. I firmly believe this after doing many, many years of proofs. If you don't know what to do, just try something. Okay. If the system is stable and nothing's happening and you need something to happen, you have to introduce chaos. And the best way to do that is to pick what seems to be a legitimate math step. Obviously, don't try something impossible, and see if it goes anywhere. Okay, so there you go. This will be kind of our last official day on talking about trig identities and verifying them. We will be using the skills developed here in the next section, which will be the most important section of the chapter on solving trigonometric equations. All right. Let me know if you need any help.